What's up guys, it's Mr. B, and today we're just going to familiarize ourselves with the PLC we'll be using. What I'm going to do is I'm first going to build a circuit today, which will resemble how a 120 volts in a normal circuit would work. And then I'm going to go ahead and I'm going to build that exact same circuit in with the PLC. And then what I'm going to do is I'm going to show you how it functions exactly the same as the other circuit, but then I'm going to adjust my code and not change anything and be able to adjust the whole entire circuit with just simply changing one line of code. We'll also go over into our software today. I'll simply show you how to put one line of code in and then how to download that to the PLC. So let's go ahead and get started.
Okay, so I'm going to go ahead and start with the code before I bring you to the workstation. And I went ahead and opened up the software that I'm using, and I'm going to go find my PLC that I have. And the one I'm using is the EZ512 DCR. So I'm going to go ahead and open that one up. And when I do this, now I need to make sure I had confirmed my connection. And I am using an USB connection, so I'm going to go ahead and put that on. I'm going to go online. I'm going to come down here, and the first thing I'm going to do is I'm just going to grab whatever is on that PLC and I'm going to bring it over to my computer. So I'm going to take whatever's on that device and I'm going to bring it to my PC. Now today we're just going to do one line of code. We're going to keep it simple and we'll build off that as we go. So I'm going to go down to a circuit diagram, and we're representing a circuit that we would do with a normally open push button to a normally closed push button to a light. And the only way that circuit would work is if you press the green button. So we're going to do the same thing, but we're going to do it in code. So I'm going to go ahead and I'm going to show you my circuit. We're going to wire I1 up to a normally open button, and then we're going to go ahead and wire I2 to a normally closed button, and then my output is going to be my light. So I'm going to say that's Q1. So I'm going to wire up a green light to Q1. And the way this works is we have now something called logical continuity. So logical continuity is everything in this line has to receive a signal of 1 in order to get to the output. So the output over here will not work until you have logical continuity through these two inputs first, because they're in series. Now we're going to talk about electrical continuity. So the signal is going to get received from electrical continuity from my system. So when I press a button, so if this is hooked up to a normally open button, and right now I have it as something called a make contact, which means it needs to receive electrical continuity through the signal to receive a 1 for logical continuity. And then we're going to come over to the I2. I'm going to wire this physically up to a normally closed button, and I'm going to leave it as a make. In other words, a normally closed button will always have logical continuity because it's normally closed until you press it. So the electrical continuity will give this logical continuity a signal of 1, and then in order for the output to receive a signal of 1, I would simply only have to press the green normally open button to allow signal to go through here. This one will already be receiving signal because it is a normally closed button, and then the output will work. It'll make more sense when you see it in action. So I'm going to go ahead and download this to my PLC by clicking on communication, and then I'm going to transfer it now from my PC to my device. And we're going to go ahead and move over to our workstation now and show you what that looks like. Okay, so now we're moving over to the station, and what I did is I pre-wired an electrical circuit over here so you can see, and then I'm going to wire it up here with the PLC and show you that it does the same thing. So right now we took line 1 and line 2, 208 volts. We brought it up to my transformer, and then my transformer is going to take that, change it to 120 volts. And then from this, I'm going to use that as my power supply to this circuit. I'm going to go in series to a normally closed red button. I'm going to leave that in series to a normally open green button. I'll leave that in series to a green light. And then I will leave the green light and go back to the transformer. So the way that should work is I would have to press the green button in order to engage it because the red is normally closed. I'm going to go ahead and unlock my system and show you how that works. I'm going to go ahead and energize, and I'm going to come up here and I'm going to press my green button, which should close the entire circuit because the red is already a normally closed button, and if you notice, the green light comes on. And if I were to press the green light and the red light, it would open it because I closed the green, but then I opened the red button, which does not allow current to flow. So I'm going to build that same thing now with my PLC. So I'm going to go ahead and turn off my system. I'm going to lock out my module, and then I'm going to go here and I'm going to build that with the PLC. I'm going to bring 120 volts, so line 1, and I'm going to connect that to my neutral over to my DC power supply. I'm going to bring my negative and my positive over to my PLC to power my PLC. I'm going to wire up my inputs first, so I'm going to make them a blue wire so it's easy to notice where my input wires are going. I'm going to take input 1, and as I talk to you about the program, we're going to put input 1 to get a signal from the green button. And we're going to say input 2 is going to get a signal from a normally closed button. Both of those buttons need to leave, so the PLC internally will send the negative side of power to these, and then it will need to receive a positive on the other side of these switches. So I'm going to bring that back to positive. I'm going to bring this one back to positive, and since everything's in parallel, I don't have to go all the way back to the PLC. I can go back to where that port plugged in. So in other words, when I press this button now, since it's open, it will send a signal to 1 and allow logical continuity to pass through input 1. The normally closed button already has electrical continuity, so it's already sending a signal, so I don't even have to press it, and it's going to pass through my make contact for input 2. So I'm going to leave now my output, and remember my outputs are labeled as Q1 with this, so I'm going to leave Q1 and I'm going to go to my light. My light is going to be my output. And I'm going to leave my light and I'm going to come back to the negative power supply or my negative source. I'm also going to, on the other side, because it's in parallel, I'm going to give it positive power. So now this output has the positive and the negative, but there is a yellow signal that's going to get provided by the PLC, the processor, that allows that to turn on based off my code. So let's go ahead and unlock my system. I'm going to energize my system, and it should function the same way. So my PLC booted up. I'm going to go ahead and click run so I can run my system. And the way this worked is, let's actually go to my program. It's going to be hard to see, but I have no logical continuity. When I press 1, it sends electrical continuity all the way over to the output because the second input is a normally closed button. And if I were to press that, I would lose that logical continuity and it wouldn't work. So it functions the same exact way as the 120 volt system, but now I have it done with 24 volts. Now, why would we do it with a PLC versus just wiring it up? If I wanted to change this system up here, I would have to physically unwire everything and wire it up the way I wanted to. When you're dealing with your system down here, I can simply change one section of the code and then it will function differently. So if I wanted to just change I1 in my code, so I'm going to go and change I1 in my code and make it a break contact, as in it's going to function, it's going to invert the way it works. I'm going to simply invert the way it works. Okay, so now what I'm going to do is I'm going to come to my code and I'm simply just going to take this make contact, which says I need to receive a logical signal of 1 or electrical continuity of 1 to allow it to pass, and I'm going to change it to a break. So now what it's saying is I will allow logical continuity to go through here when I'm not receiving an electrical signal. So since this is hooked up to a normally open push button, which does not get a electrical signal, this is going to allow logical continuity to pass through without pressing anything. So now this hooked up to a normally open button will allow a signal to go through without pressing anything, and then the make contact hooked up to the normally closed button is allowing a signal to go through when it's not being pressed because it is sending a signal. And then you're going to go ahead and get your output, which is your light, which will work with nothing being pressed. So all I did is simply just change this, invert the way it works for my normally open button, and now I'm going to go ahead and take that and send that from my PC back to my device, and we're going to go see how that changes the system. So we're going to go ahead, we're going to run it into run mode, and if you notice, I'm not pressing anything and the green light turned on. So I didn't have to rewire anything. All I did is simply change my program and it adjusts the way the code works. So I hope this was helpful. This is just one line of code. We're going to add to this as we go.